Thank you for introduction. My name is Yuki Yasuda from the Science Research Laboratory of NHK, Japan Broadcasting Corporation in Tokyo. Okay. Today I'd like to tell you about our study metadata generation in the AI era, multi-level indexing for more efficient news production. Right. Introduction. The background of this work is that broadcast companies create a large amounts of text data in the process of producing content. For example, there are news articles, scripts for programs, and maybe proposals for programs, and so on. The most common texts are often news articles, which are one of our main content areas. So we focus on news article in this study. Right. Okay, the best way of organizing large amounts of text data is by adding accurate and rich metadata. Some metadata is added automatically, like timestamps, but it does not help humans to understand the content. So we should also add rich metadata that allows humans to quickly grasp what the content is about, like labels that indicate the topics of an article. Such metadata benefits both creators and viewers. Producers can efficiently retrieve and use past material in the creation of new content, and viewers can easily access articles that they want. Conventionally, metadata indicating content has been added to text data manually. It means somebody must read and understand each article, then add appropriate metadata. In recent years, the amount of text data that needs to be handled has grown very large, and variation due to manual input can undermine the utility of the database. So it is very costly and error-prone to add labels to news articles manually, especially for local broadcasting stations that have limited resources. Fortunately, recent rapid advances in computer science have given us powerful tools indicating artificial intelligence. It is becoming possible to entrust computers to some degrees with such advanced tasks as support tools. So we have developed a system that adds labels to news articles to support search, classification, and content creation. Right, now I like to outline some of the features of our system. The system assigns labels indicating the genre and topics of news articles entered through a web-based interface. This figure shows the workflow of publication of news articles and how our system can support the workflow. For example, it can retrieve articles related to manuscripts currently being written and extract keywords, topics, and genres for each article. Right. Here's an example of a system. Working? Okay. Here's an example of our system. The input text can be a complete news article like this, or it can have no title or be working in progress. It's okay. All right. The article has the title and the body. These are the output button. These are the genres, and these are the labels that the system gives us. If you want more specific topics like proper nouns, the system can also extract and highlight keywords that appear in the text, like that. Also, the system can list articles from database that are related to input article. This is keyword like human name. For example, Mark Zuckerberg and Meta OpenAI, ChatGPT, like that. Microsoft. Yeah, company name. Okay. Right, I will briefly explain the background technology used. Yeah, one of the core components is multi-level text classification, which is a major task in natural language processing. The task is to assign an appropriate set of labels to a text document. Most real-world documents, including news articles, contain multiple concepts and topics. For example, simply labeling an article about a tennis match as sports would be very useful. Would not be very useful. We can organize the data more usefully by adding more detailed labels such as tennis and Wimbledon as metadata too. Yeah, this figure shows a typical procedure for multi-level text classification using neural networks. Our system also labels news articles using a process that follows this procedure. Right, first, the article provided by the user is segmented into tokens necessary to process natural language with neural networks, which use a dictionary to map word into corresponding vectors for processing. The tokenization process makes a matrix of word vectors from the unique vectors assigned to each token. The word vectors are then fed into language model. For simplicity's sake, I have described the classic BERT model here, but the basic process is the same even if we use LLM like GPT and Llama 2, Llama 3, and so on. In fact, our current system uses LLM trained on Japanese data. By the way, about BERT network, type of transformer neural network that is known to deliver stable performance in many natural language processing tasks. BERT uses attention techniques to aggregate information that represent the characteristic of the entire sentence into the first special so-called class token. The system treats the output vectors of this special token as vectors representing the meaning of the entire document and extract it. And finally, the system feeds the extracted vector of special tokens into a feed-forward neural network. The vector dimensionality is fixed at 768 for BERT. However, the number of labels we want to apply is not necessarily 768. The feed-forward neural networks convert the document vectors that represent the meaning of sentence into score vectors whose dimension is the number of labels we want to classify. The system calculates a score, that is probability, for each labels and outputs those labels whose score exceeds a threshold. In this way, the neural network outputs appropriate labels for news articles. Right. However, there are several challenges associated with these tasks. News articles deal with many real-world topics. Labels describing major genre areas may be relatively common, while labels representing unusual topics can be extremely rare. This figure shows the distribution of labels on the Reuters dataset. This is really famous benchmark dataset in natural language processing, consisting of economic news and labels for 19 topics. About 4,000 documents with the label earn exist, while only 2 documents with the label castor or exist in the dataset. A major issue in news classification is known as label imbalance, which describes the vastly different frequencies of labels in the training data. When neural networks are trained with datasets including very infrequently occurring labels, the classification accuracy drops because there are insufficient samples in the dataset for the model to learn well. Because news articles cover many topics, there are many low frequency labels, reducing the overall accuracy of the model. Right, our method. Our method aims to tackle this problem, but this is very, very technical part. Yeah, so complexity. We train the model by making its actual output probabilities approach the desired probabilities, which are 1 for labels that we want the model to output for each article in the training set, and 0 for all other labels. The so-called loss function measures the difference between the actual and desired set of labels, and the neural networks is trained by gradually reducing the loss. The loss is sum of the losses from each label, so the total loss is sum of losses from each label. So to tackle label imbalance, we apply a weighting criterion that reduces the strength of learning of the labels that appear with high frequency, and increase it for labels that appear with low frequencies. Also, for any given samples, most labels are negative, and the total loss is dominated by the losses from negative labels. So we also applied another weighting criterion that reduces the strength of learning for negative labels and increase it for positive labels. Right. And the combination of these two types of weights adjusting the strength of learning of the model is our method's first approach. Another approach is label smoothing. As I said earlier, we train the model by making its output probabilities approach the desired probabilities, which are either 1 or 0, completely positive or completely negative. Yeah, this might seem a little unnatural. For example, there's an article about tennis and Wimbledon have no relation at all with the label US Open. It is unnatural. If the article is about international tennis championships, the label US Open may have some relevance. So we adopt technique that distributes some probabilities from positive labels to relevant but negative labels. This allows the model to learn relevant labels even if those labels really appear in the dataset. Whether labels are related to is determined whether they co-occur in many training articles. So the second feature of our approach is smoothing the labels and adjusting the desired probabilities that the model is trained on. Okay. The proposed method significantly outperforms the baseline method on benchmark dataset, but it is not important. So please ask me later if you want. The system has been introduced for testing at local broadcasting stations. This is use cases. Last year, producers at the local station wish to create a ranking by topic of news articles published on the local news website over a year. The news articles were not annotated with topic metadata. We used our system to automatically assign labels and re-aggregate the published data from 121 articles by topic. The labels automatically assigned by the system were manually reviewed and confirmed. The rankings were then shown on news programs to help viewers visually grasp local events from the past year. And it was confirmed that the system could reduce publication time, producing time, publication time on budget. Okay, next one. Each regional NHK station publishes local news on its website, but unlike the national sites, articles are not labeled due to limited staffing. It is hoped that our system will allow efficient metadata addition even with few staff, so viewers can access such information associated with local services. In the article published, workflow producers input completed pre-production news articles into the system. They then check and correct the output labels and manually enter the new labels if necessary. Labels constructed in this way are then published on the website alongside the news articles and displayed as hyperlink to related article. This improves page viewers per visit by local viewers. Okay, the system has achieved a reduction in the effort required for content production, although we have identified some workflow issues that remain to be tackled. First, the labels defined in this system are intentionally constructed to be a common word, but producers in local regions want more specific local labels and proper noun to attract the interest of local viewers rather than generic terms. Second, when using the system for local contents reuse, it was reported that the system's interface was not good fit with the local production workflow, resulting in insufficient use of time. Yeah, our system, including its interface, was initially designed for national use. So we think we should implement an interface more suitable for local workflow, including, for examples, batch processing interface. Yep. Okay, up until now we have been talking especially about labels. However, we should mention the other metadata. So our goal is to create high quality content, not to organize data. From the point of view of metadata assignment technology, computers are great. Computers is a great help. If the system can assign appropriate metadata, humans can devote their resources to more essential tasks. Ideally, in the future, all we will have to do is create basic content, such as the main article text, and the system will provide all possible metadata. Of course, currently, no such system exists. It is difficult to predict what type of metadata will be needed. So we need to develop our integrate various metadata addition technologies. Right. We are currently developing a system that assigns various types of metadata. We have already implemented the prototype, and we are looking to test the system in production environments. The system automatically assigns auto-generated titles, genres, labels, emotion tags, and speculative location to our news articles. The system takes only the article body and produces appropriate metadata from it. So in theory, we only need to write the main text of the news articles, and the article will be ready to be published. Of course, a human checking process is essential in practice. It is clear that genres, labels, and keywords are useful as basic metadata. This system also assigns metadata that is not very common, such as locations and emotions. These metadata are not very effective for single article. Rather, they are valuable as material for analysis news data. Yeah, one specific example of using location metadata in NHK is visualization of coverage locations. Japan is a country that is prone to disasters such as earthquake and typhoons. For this reason, NHK focused frequently on reporting such natural disasters. In 2024, a major earthquake occurred on the Noto Peninsula in Ishikawa Prefecture. After the earthquake and aftershocks has largely subsided, we verified which areas were most mentioned in the articles we published. The results are shown in this heat map figure. Yeah, if location metadata is attached to each news article, it is possible to visualize the locations covered in real time. This may help to clarify where we should go to cover stories from places that have not yet been covered. This is somewhat smarter way than using a checklist of places to cover, especially when reducing or limited in the events of a disaster. Yep. Opportunities for content reuse and data analysis using metadata can come suddenly. In most cases, it is difficult to quickly prepare the resources to add metadata to large amounts of contents. This means that metadata must usually be assigned in advance. For example, there is no effective way to use the emotion tags attached to news articles, in fact. However, this does not mean that it's a waste of time to develop technology for adding emotion tags. Someone may come up with an effective way to use them in the future. Ideally, it would be best if content was labeled with all the metadata we can think of. Okay. However, manually assigning many types of metadata greatly increases the cost of the task. So ideally, we should create a system that assigns metadata automatically as far as possible, and create an environment where humans can focus more on effective work. Right. In the future, we plan to build a multimodal model, particularly one that treats both text and image data. Many news articles include not only text, but also images, as you know. For example, if a system could extract appropriate thumbnail images from video material to match the main text of news articles, it should be possible to archive further costs reducing. We also want to extend the system for use beyond the news domain, because the large amounts of text data we manage are not limited to news articles, of course. If these systems were applied to all types of documents we have, our work might become much more efficient. Right. Okay, thank you.